In this unit, we're going to be talking all about congruent triangles, proving triangles congruent, so more proofs ahead. But first we need to start looking at triangles and how we classify triangles and know all the parts of a triangle before we get there. So that's what this section is about. So we are on classifying triangles, and we classify them two ways. We classify triangles by their angles and by their sides. So this we've known for a while. If you have three acute angles, that is called an acute triangle. And that just means all angles are less than 90 degrees. Okay? When you have an obtuse angle, when you have one obtuse angle, that's called an obtuse triangle. And that means one angle is greater than 90 degrees. When you have one right angle, that's called a right triangle. And that means one angle is equal to 90 degrees. When you have three congruent angles, and remember that's the mark of congruency, all angles are congruent, so what do these measurements have to be? If there are 180 degrees in a triangle, these measurements each have to be 60 degrees. So all congruent angles of a triangle will always be 60 degrees if they're all the same. And that's called an equiangular. Equiangular triangle, because they're all equal. So that's how we classify them, by their angles. If you look to this picture to the right, and I look at triangle CDE. So if I outline CDE and I see this triangle, this right angle right here, I know this is a right triangle. And I can use that symbol to abbreviate for triangles. So that's a right triangle. If you look at let's get that off there. If you look at BCE, you'll notice you have this one obtuse angle, so it makes it an obtuse triangle. See if you pause it, fill those out on your own, and see if we get the same thing. Number 3, hopefully you're back. Number 3, you should be getting equiangular. For number 4, triangle BDE, that's an obtuse triangle. And number 5, you should be getting acute triangle. All right? Now, that's when we classify them by their angles. When we look at by their sides, here's what I like to think about, and this makes it easy for me, is that if you look at the capital letter E, 3 lines are parallel. If 3 lines are the same, that's equilateral. You have an equilateral triangle. Three parallel lines in the word equal, 3 equal sides, equilateral triangle. When you have 2 congruent sides, the letter I has 2 parallel lines. That is an isosceles triangle. So 2 parallel lines, 2 lines congruent, isosceles. When you have no congruent sides, the letter S has no parallel lines. That's a scalene triangle. Okay? So that's when we classify them by their sides, and now we already looked above about how we classify them by their angles. So when you look at these pictures on triangle 6, or number 6, if you look at JKM, no sides are the same. So right away, I know that it's a scalene triangle. And this is just by its sides. We don't know anything about the angles right now, so we can just classify them by their sides. So look at 7 and 8, see if you can figure those out on your own. So number 7, we should be getting isosceles triangle. And for number 8, we should be getting equilateral triangle. Okay? Now, when we look at them both by angles and sides, here I know it's a right triangle because of this degree. 2 lines are the same. So this is a right isosceles triangle. No abbreviations except for the triangle, right? Isosceles. Number 10, I don't know anything about the side, so it's scalene. And I know one angle is greater than 90, so it is a scalene obtuse triangle. All right? Number 11 is equiangular, equilateral, triangle. All right. Number 12, I don't know anything about the angles. I don't know. Well, the angles are all less than 90 because there's not one that's greater. So it's an acute scalene triangle. Number 13, nothing about the sides, and it's right, so it's a right scalene. And number 14, two sides are the same, one's greater than 90, so it is a isosceles obtuse triangle. Okay, so that's classifying. Hopefully that part's pretty easy. Now, if you look at this picture, first let's look at this. It says if PR is bisecting SRT. So if PR is bisecting SRT, I know right away that this angle and this angle are congruent. That's what it means to bisect. Cuts it straight in half. So I can make those markings on my diagram. U is the midpoint of RT, meaning these guys are the same. So I can make marks to my diagram. That's what I had to do first when I read the directions. That's why reading directions are so important, because once we read that, now I can make corrections to my diagram and look at the picture. So I want you to go through 15 through 20 and tell me what you get when you label those. All right, so hopefully you pause me and you're back. So 15, you should be getting obtuse isosceles. Number 16, you should be getting equiangular equilateral. I know my writing's terrible. Equilateral. Number 17, we should be getting right scalene. Number 18, we should be getting obtuse isosceles. Number 19, we should be getting equiangular equilateral. I know I'm abbreviating and I shouldn't be. And triangle PQT is a right scalene. So if you're struggling with how we got those, please, please, please come and see me. All right, so here, I'm only going to do a couple of these with you. Number 22 we'll do together. What we have to do here is we have to find the distance. If we're classifying by their sides, we need to find the distance of all these. So if you look here, and I'm making up points in space. -3, 2, we're going to call that J. We're going to call this 2, 6, and we're going to call L 8, -1. So that means I'm going to use the distance formula 3 different times. I'm going to find the distance here, the distance here, and the distance here. So we've already done the distance formula this year, so I want you to recall what the distance formula is. You'll remember distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So I will walk you through this one. So first I'm going to find the distance of KL. So the distance equals, and I'm going to call this one x1, y1, x2, y2, so I don't get lost in translation. So I'm going to say 8 minus 2 squared plus -1 minus 6 squared. You see where I got that? 8 minus 2 squared plus -1 minus 6 squared. So when I complete that, I get 6 squared plus -7 squared. And I get 36 plus 49. And 36 plus 49 is that 85? Square root of 85, is that right? KL? Yes. So square root of 85. So I'm going to say KL is the square root of 85. Now I'm going to find the distance of JL. I'm going to erase this. Notice I'm keeping it in extended form. So now I'm going to find JL. I'll write JL over here. And again, I'm going to call this X1, Y1, and I'll keep that as X2, Y2. And I'm going to do 8 minus -3, careful, 8 minus a negative makes it a positive, and then -1 minus 2 squared. So here I have 11 squared plus -3 squared, making it 121 plus 9. 11 squared is 121, -3 squared is 9, so JL is the square root of 130. Okay? And the last distance point that we're going to use is here. And I'm going to call this one x2, y2. And I'll keep that x1, y1. So now JK is going to be -3 minus 2 squared plus 2 minus 6 squared. And I get -5 squared plus -4 squared. -5 squared is 25. 4 squared is 16. Add them together, and I get square root of 41. So now that I have done all these distances, are any of them the same? No, they're not the same, so I know that this is a scalene triangle. So not a lot of work for one problem, but a little bit of work. So I want you to work out, so on your notes, when I check your notes, I'm going to be looking to see, is the work here? Is the work here? So I want you to work out 23 and 24 and tell me what you get. So here, we shall pause it and come back. So on 23, you should be getting isosceles. And then 24, you should also be getting isosceles. So I'm going to check your work in class to see, did you really do it? And if you're struggling with how I got those, of course, you'll come to see me in tutoring. Good luck.